Good morning, everyone. Welcome to today's session. So, in Unit 3, Recurrent Neural Networks, as a part of AD3501 Deep Learning course, we are going to discuss about the recurrent neural networks topics today. So, I am Ashagila Devi, Assistant Professor from Department of Computer Science and Engineering at Rohini College of Engineering and Technology. So, let's begin our journey in understanding how the machines learn from the sequential data. So first, introduction to recurrent neural networks. In a traditional neural networks, each input is treated independently, but in real world situations, the data comes as a sequence like sentences in a paragraph, frames in a video, or strike prices over time. So the recurrent neural networks, or RNN, are especially designed to handle such sequential data. So RNN have an internal memory that stores the information from the previous input and uses this memory to make the better prediction for the next input. So because of this property, RNN are widely used in speech and voice recognition, natural language processing, and time series prediction and pattern recognition. So in short, the RNN learns from the past to make the decisions about the future. So why recurrent neural networks? So now why do we need RNN when we already have a feed-forward neural network is? So the feed-forward neural network only looks at the current input. They cannot remember what happens in the previous step. But many real-world tasks depend on this context. So for example, when we reading a sentences, the meaning of the word often depends on the previous word. So RNN solve this by maintaining an internal memory state that carry forward from one input to the next. So therefore RNN are then ideal for applications like speech, text, and time series forecasting and any type of sequential processing. How the recurrent neural networks works. So let us look how the RNN work internally. In an RNN, information flows through the network in a loop. At each time step, the RNN receives as an input and also receives the hidden state from the previous time step. This hidden state act like memory. So unlike deep feed-forward network with many hidden layers, the RNN uses same layer repeatedly. So looping through the sequence until all the steps are processed. So weights and bias remains the same for every time step, which makes learning efficient while preserving sequential context. And feed-forward versus recurrent neural networks. When we compare it, a feed-forward neural network processes the data in one direction and has no concept of time or memory. So it is good for tasks where the inputs are independent and such as simple classification or regression. On the other hand, the recurrent neural networks maintain an internal state, allowing it to understand the relationship between data over time. So that makes the RNN more suitable for tasks like language modeling, deep recognition, and sequence analysis. So next is applications of RNN. The RNN are used in almost every domain involving sequential data. Some popular applications involved image captioning, that is generating text description for the images, and time series prediction, that is forecasting stock prices or weather conditions, and natural language processing, that is tasks like sentiment analysis or text classification, and machine translation, which is translation of text from one language to another. So these application requires a model to understand context, order, and pattern. So something for what we are applying RNN over here. And the advantage of RNN. So the recurrent neural networks come with several advantages. They have handled variable length sequence efficiently. They remember the past inputs and provided better context and understanding. And the parameter sharing reduced, and so the model complexity is also reduced. And next, the non-linearity activation functions allows complex mapping, and their sequential processing matches the natural structure of the time-based data. So overall, RNN are flexible or powerful for sequence-related tasks. So what is the disadvantage of RNN? So despite of its strength, RNN has its own limitations. They suffer with vanishing and exploding gradient problem. So making training difficult over it makes the training difficult over long sequences. They are computationally expensive because they process input step by step, and long-term dependencies are hard to learn efficiently, and they cannot be easily parallelized due to the sequential nature. choosing this right structure and tuning parameters are most complex when you are using RNN. So these challenges are led the development of advanced variants like LSTM and GRU. So that's about the recurrent neural networks. Thanks for listening.